All right.
I still prefer the canary because canaries are amazing.
I told one of my students, I was like, if I tell you, I'd have to kill you. And they'd be like, one of them was like, it'd be worth it.
It's a new line, Gen Z.
So f of 0 is 1, right? Because when x is 0, y is 1.
Oh, we're going over.
So I'm just going over them.
Oh.
So that means that my c is 1. Because we know that whenever whenever x is 0, yeah.
I thought it was 5.
Oh, I'm sorry. You're right. That is 5. I'm just going off of my bad. F of 0 is 5. Whenever x is 0, y is 5. That's my y-intercept. That's my c. Also think it was our initial amount, our starting amount when x is 0. So c is 5. F of 1 is 1. So if you want, sorry, I should back up a little bit. If you want to find this the regular way, you'd say, okay, I have my formula. Y equals c times a to the x. So I'm going to plug in 0 in for x, 5 in for y. Right? So I'm going to substitute in sub in 0, comma 5. And I will get 5 equals c times a to the 0. But we know a to the 0 is always just 1. So that means that 5 equals c times 1, which is just c. Is everyone okay with that part? If I just leave it like that?
If that's completely confusing, we could do a times 0, which you know is 1. And then
yeah, and then just divide both sides by
1.
Yeah.
5 over 1 equals.
I got 1 equals 5a and divide each side by 5.
That's later. Wait, for this part here?
Yes.
So here, you don't need to. What's being multiplied by c? C is being multiplied by 1. So you divide both sides by 1, and you get 5. Does that make sense?
I guess.
Or you could just leave it as is. I think that's easier. So anything times 1 is just itself. Think about it like that, maybe. So c is 5, I think. All right, so then the next part here. So now we know that c is 5. So we know that our formula at this point is y equals what? What's my c? 5 times a to the x. So now we're going to use our next point. F of 1 is what? 1. Yes? So why am I even asking you guys? You're not responding even though you all have done this. So we have 1, comma 1. We're going to substitute that in to this here, and we'll get 1 equals 5 times a to the 1. A to the 1 is just a, so 1 equals 5a. Now we're going to divide both sides by 5, and you all got a is equal to 1/5. So our last step is to write the formula. Y equals c 5 times a 1/5 to the x.
A really pretty song.
What was that?
A really pretty song.
Thank you. All right. So now we're moving on to our next one, which is Exponential model intro. Fox?
I spelled it with an E instead of an F.
Okay. All right, I spelled your name correctly, so I'm not going to worry about it. You're thinking exponential is what you're thinking. Exponential functions. Eric, read for me.
Exponential functions are widely used to model a variety of real-world situations. Exponential models fall under one of two categories. Those that represent exponential growth and those that represent exponential decay.
Mhm.
Exponential growth. In 1985, there were about 203,000 cellular phone subscribers in the United States. This number increased to about 84 million users in 2000. The rapid growth in cellular phone subscribers in millions can be modeled by the exponential function f of x equals 0.0272 times 1.495 x to the negative 1,980,
Great.
where x is the year.
Perfect. You can leave it there. That's good. So remember, my function is y equals c times a to the x, where c is my initial amount. In other words, my starting amount, or my y-intercept, like we found last handout. And a is my base, also known as my growth factor or decay factor. Growth I'll put slash decay, I guess. But you know, I always call it the growth factor, even if it's going down. If it's going down, then it's a decay factor. But you can call it just a growth factor that's going down. That's fine too.
When it decays, will it almost always be a fraction or decimal?
Exactly. That's awesome. So when it's decaying, it's when it's less than 1. It's between 0 and 1. So it's a fraction. When it's a fraction between 0 and 1, that's when it's decaying.
Okay, so you
Yeah.
know when it's going to be a decimal by knowing if the equation is talking about a growth or decay.
Yes. You're about half an hour ahead of us, but yes, we will totally see that.
What if it's a mixed number? Like, then it's still gonna have a fraction in it.
When it's larger than 1,
Yeah.
then every time you multiply by something larger than 1, it makes it bigger. So this is my multiplier, in a sense, my growth factor. So when my growth factor is bigger than 1, the number gets bigger each time. So my growth factor, so what's my C here? What's my C?
0.02.
That's my C. That's my initial amount. So that means I started with this many people. We started with in 1980. Wait. It's 1980. They didn't tell us. Okay. So 1980. In 1980, there were this many million cell phone people. So it means that there are 27,000 cell phone people in 1980. They didn't tell you in 1980, but okay.
Well, it says in 1985 at the right.
Right. So, but they talked about 1980 as my initial amount. Initial was my starting spot. So that's kind of. Oh, at any rate. So here we have this. But let me ask you this: what's the multiplier? What's my initial amount? 0.0, like you said, 0.027, my C, right? What's the base? What's my base? What's my A?
1.495.
1.495. Good? Oh, I should at least keep the colors consistent, right? Darn it. So initial amount is my C, and that was 0.0272, and my base A is 1.495. Okay, good. All right, so now we're going to evaluate 1980. So in 1980, I'd have y equals 0.0272 times 1.495 raised to the 1980 minus 1980. What's 1980 minus 1980? 0. So this becomes 0.027 times 0.1495 to the 0 power, which is what? Anything to the 0 power is just 1. So this becomes 0.0272. Now we need to interpret that. This is millions. 0.0272 million is the same thing as 27,200. So multiply this by millions, right? So this would be,
Moving the decimal over to.
yeah, moving the decimal place over, technically 6 times, right?
Oh,
So then we'd get 1, 2, 3, 4, then we'd get 27,200. Yeah. 27,200. So what does that mean? What does this mean? F of 1980, that means when X was 1980, so in 1980, right? In 1980, there were 27,200 cell phone users. That's what that means. Or you could say 0.0272 million. Point 0.0272 times 1 million would be 27,200. I'm less worried that you get from here to here so much as you understand that there were this many million in 1980. Are we okay with that part at least?
No, where's the million?
It says
The got
million.
dropped. I know, but over here on this answer, so it's 27,200 million?
No. 0.0272 million. 0.0272 million is 27,200. This is million. Times 1 million. Right? We have that many million. So that's 27,200 people.
So you said you moved the decimal point 6 places?
Well, I just multiply it by a million.
Or
Just multiply it by a million.
hypothetically, can you go for 6 times 100,000?
So 0.0272 times
100,000.
a million.
On the top calculation here, 0.272 times, one more up.
Million.
No, one more up.
The 1.4.
Yeah, that
you
doesn't
don't
come
have
up
To the 0 power.
Oh, so it's just to the 0, okay.
Yeah.
Two zero,
I got
which makes it into 1.
One,
one.
oh, okay, I got it.
Yeah.
Okay.
So should I just, I'll do this. 1. Is that better?
Okay,
If I do it like that?
okay, that equals one.
Okay, yeah.
Okay.
Yeah. All right, people feeling okay about this now? Yeah, we kind of talked it through, it's good. Yeah. We're going to try it for 1995. So here we'll have y equals, what was the number? 0.0272 times 1.495 raised to the 1995 minus 1980. What's 1995 minus 1980? How many years is that?
15.
15, perfect. So I'm just going to plug that into my calculator. So you don't have to write this part down if you don't want to, but you can. Times, see if you can squeeze this into your sheet, times 1.495 to the 15th. So now we're going to find out what that is. All right, so let me bust up my calculator. I'm going to start from the inside and work my way outwards. 1.495 raised to the 15th power. Good? And then I'm going to multiply it by times 0.0272. Done. 11.33. right? So that means that I have, so now we need to interpret that. What does that mean? That means that in what year? In 1995, what? There were 67 cats in the world? What? 1995,
They were 113,288,752 cell phone users.
yeah, I'm just gonna put, you can totally put that. I'm just gonna put 11.33 million because I'm
It
lazy.
would be 113. Wait. No,
11.33,
11.36.
yeah, million cell phone users. Cell phone users. Yeah. Right, because when you plug this in, 1.495 to the 15th power times that, you get 11.33.
I just got 113.288.
Oh, did I do it wrong?
I don't
Oh,
know.
no, you would say 0. That's
Did
what
you
I
do
was-
0.02?
0.02, not 0.2.
Yeah.
I made this number.
Oh, yeah,
Oh, it's not 0.
0.02. 0.02.
Oh, okay,
Yeah.
I got you.
0.0.
Yeah.
0.02. Yeah, that's right.
So I'm gonna, don't worry about the graphing part, I'm gonna show you here on Desmos. So we have 0.027 times. Okay. So if you look at,
Million cell phone users in 1990.
Oh, we don't have to put 6 zeros, we just put 1.
yeah, just put million, it's easier.
0.33 million.
So as you can see, cell phone users starts off kind of slow, 1980, and starts picking up steam, 1985, 1990, 1995, it starts to really kind of grow there, right?
Did you see the pocket phones in 1990?
I had one. Oh no, 1980, you're right. They were huge. They were in the cars. Did anyone ever see Pretty Woman?
Yeah.
How that the dad's in his car with his big old car phone?
Mm-hmm.
And that was like in 96 or 97, 98. Or sorry, 88. And the little kid's got his little toy car phone.
They had the side pack ones where you could
Yeah.
walk around with a big
The
strap and it was huge like
giant.
this.
It's
Yeah.
like they're basically putting up a brick against the
Yeah, they were huge.
They had the Motorola brick came out.
Back in those days, yeah. So there weren't that many of them back then, and even they were starting to become popular as car phones, kind of right around the '90s, late '80s, '90s, right in this range. And then it wasn't really until after '95, even 11 million is not that many. You think about we have 330 million people in the United States. It's a really small percentage, but now there's tons.
It became much smaller and they carry around in purses and pockets.
Exactly. So we're going to evaluate, you know what? Instead of evaluating 1996, I'm going to do it here. So 1996, what year is 1996? 16?
Oh, 16, that's 1980.
Yeah, so 16. So we'll just do it on the graph here. 16 is 16.937. I'll write that down. Or here, I'll do it this way. No, that's right.
That's a percentage.
Here, I'll do it this way. X minus 1980. How's that sound? Oh, no.
Where do we write that?
Minus.
Okay, I wrote the whole equation. Yeah.
Oh, no.
I tried to put the square root sign.
Yeah, I'll try that. X
Highlight it?
minus 1980. Oh
Maybe if
dear.
you highlight it and then,
Parentheses maybe?
yeah, parentheses.
I'm gonna try this one more time.
I should just do 15 or 16.
I know, but I want people to kind of
But you're gonna have to do
feel
it
better
twice.
about the years. Ah. There we go. Okay, now we have it. All right, so we wanted, what was it, 1996 and 1995? Did we get 1996?
Yeah.
16.937?
Yeah. 16.937, everybody has that?
Yeah.
And what do we have for 1995?
We have 11.33.
So f of, let's write that down. F of 1996 is equal to, you said was 16.937.
937.
And so comparing that to 1995, we have 16, so we're gonna do 16,937 divided by what did we get for 1995?
We're still in Desmos. We can't see what you're doing.
Oh,
It'd be 11.33.
11.33.
That's what.
Okay, everybody divide those.
This is fine.
Everyone guess what you think you're gonna get. What do you think you're gonna get?
1.5.
Maybe 1.5-ish.
No, here.
Specifically, you should get. What's my growth factor? What's my growth factor? Everyone find the growth factor. Y equals c times a to the x. What's my growth? What's my base? What's my growth factor? 1.495.
494. Yeah. Oh, well, you
One
rounded?
round it up.
Oh.
Yeah, when you round it,
495.
1.495. That's my growth factor. So that makes sense. Now we're going to buy 1997. Let's get back over here. 1997. 1997. There it is. Can everyone see it?
25.32.
25.32. I'll write it down. 25.32. F of 1997. 1997, 25.32.
Where do we write it down?
On the,
Alright.
And then you just do that divided by 11.33?
divided by 16.99,
937.
the previous one.
Oh,
You shouldn't get this.
Yeah, we should get 1.495. If not, there's something wrong. What'd you get?
1.495.
Yeah, 1.495.
so it's constant growth?
That's constant growth. That's my growth factor.
Yeah.
Yep, it's constant growth. It's a constant multiplier. It's a constant factor. So exponentials increase by a constant factor. My A increased by multiplying by A.
So in real life, this graph would have some outliers.
So actually, this was an 8.
That's because they rounded up the 25.32 on the graph most likely.
Oh, okay. Yeah, the slightly different ones you really carry it out. When we do the calculation.
Depends on the graph.
They increase by constant factors. So that's what you folks have sort of noticed, right? 1.495. Good. All right. Let's take a look at the next part. So if something does not change from year to year, each year you have the same amount of it. In other words, you have 100% of it. When exponential growth occurs, that means that you have more than 100% of it, right? So if my A is 1, it just stays constant. It doesn't grow at all. My A is larger. So in this case, the number of cell phone users increased by 49.5%. Why am I using my fingers when I have my board? It increased by 49.5% each year. That means it grew 49.5% each year. So my growth factor was 100% plus 49.5%, 149.5%. In other words, 1.495. So how did I get from percents to decimals? So think of it like this is 149 cents. If I had 149 cents, so percent is like cents. If I had 149 cents, how do I write that as a decimal? 1.49 in dollars. Does everybody agree with me? So that's the easy way to get back and forth from percent to decimal. Is remember percent is just how many cents you have. I have 149 cents. I write that as 1.49, and then whatever numbers come after that, you just write them afterwards. 149.5, I just wrote 1.49, and then the 5.
Just divide by 100, right?
Yeah, or divide by 100 if you remember that.
Oh,
Yeah.
or just move the decimal place.
So yeah, so remember your base is your growth factor. Now decay is a little bit, is similar but different. Fox, read for me the exponential decay part.
In a laboratory, a culture containing bacteria is treated with an experimental drug designed to kill the bacteria slowly, so as not to harm an infected host. The function f of x equals 5 times 0.75
To the x.
to the x models the decrease in the number of bacteria present in the culture, where x is in weeks and the number of bacteria present is in thousands.
Perfect. Okay. What is my multiplier? What's my C? 5. What's my base? I would find the base.
0.75.
Yeah, 0.75, 0.75. So,
So that's A.
yeah, that's my A. All right, so interpret f of 0. Evaluate f of 0 and interpret the result. So put in 0 for x and find what you get. Everybody do that. Put in 0 for x and interpret what you think the result to be.